So for the third part of this question, it's asking us to carefully sketch the initial, intermediate, and final, um, mass transport profiles. So what I've done here is denoted that H2O is in black and D2O is in blue. And looking at the mass concentration profile, we have H2O at 1,000 kilograms per meter cubed and D2O at 1,100 kilograms per meter cubed. And in the beginning stages, there's not too much really occurring. At t equals 0.1 seconds, the barrier was just removed, so there's not much diffusion occurring. But at t equals 60 seconds, at the intermediate step, we see that the D2O begins to cross over to H2O and H2O crosses over to D2O. And then in the final step, we have two horizontal lines, D2O and H2O, D2O being at 550 kilograms per meter cubed and H2O being at 500 kilograms per meter cubed. And that's due to the fact that we have divided the densities in half. So looking at the molar concentration, roughly a similar situation occurring as mass concentration up here. And we have the H2O and D2O separated, and at t equals 0.1 seconds, just the slightest amount of diffusion occurs. But at the intermediate stage, at 60 seconds, we see that the D2O and H2O begin to mix together, and there is, at the final stage, at t equals infinity, there's only one solid line, and that's because the molar concentrations are very, very similar, and this shows us that everything has diffused together, and now the liquids are in equilibrium. The mixture is in equilibrium. So looking at the molar diffusive flux, we have 2.78 and negative 2.78. 2.78 is for H2O, and negative 2.78 is D2O. And when we were solving the problem, we stated that H2O was on the left and D2O was on the right, and we created a positive gradient from H2O to D2O, meaning that D2O is going to have a positive molar diffusive flux, and H2O is going to have a positive molar diffusive flux, and D2O is going to have a negative molar diffusive flux. And in the beginning stage of diffusion, there's a little bit of there's just a small amount of diffusion going on, which is why the lines are not as steep or not as flared out. But then at the intermediate step, at t equals 60 seconds, we see that the lines are starting to become more and more spread out, meaning that more and more diffusion is occurring. And where there's still horizontal lines towards the end, that's just showing that diffusion has not occurred there. It's still water on this side, for example, and it's still D2 on this on one side, for example. But then at the final stage, the molar diffusive flux becomes relatively the same for H2O and D2O, and we get one horizontal line showing us that everything has reached equilibrium and there's no more diffusion occurring. And so looking at the total mass flux of the entire system, we have, in the beginning stages, there's a mass flux of negative 5.56 times 10 to the negative third. And that's because we just removed the barrier again, so at t equals 0.1 seconds, not too much diffusion is occurring, but which is why our lines are more steep. And then when you look at the intermediate graph, the lines become less steep, but it still shows that there's still diffusion occurring. And at the last graph, the final graph for the total molar flux, to total mass flux, there is a straight horizontal line, and that just denotes that equilibrium has been reached and there's no more diffusion occurring within our system.